Hi everybody, and welcome to a chilly Seattle. I was going to do a joke this morning about how cold it was here, since Tom's from Texas, but what was the temperature when you left Dallas?
It was like 36 when I left Dallas, so I have no reprieve from the cold weather.
Okay, so I know it's probably colder for you out there if it's snowing where you are, but Tom pretty much killed our intro joke. So on with the presentation. We're here today to talk about MonoGame and writing Windows Phone and Windows Store games with MonoGame. Just a brief summary, MonoGame is an open source version of XNA, and we're going to talk today about how that runs on Microsoft platforms. So let's get to the slides.
So this is Andy. I'm Tom. I'm a programmer at Sickhead Games, a studio in Dallas, Texas. We're a small indie. We've been around for like a decade at this point, which is lucky for an indie. And we've worked on all kinds of different kinds of technology, from Unreal Engine stuff to Torque Engine stuff to MonoGame right about now. For us, lately we've been doing some ports and things, and for a while now we've been managing the MonoGame open source platform.
And my name is Andy Dunn. Many of you out there watching are probably XNA programmers, since we've been pushing it pretty hard. And you probably know me. Maybe many of you have not seen me, but you've probably seen me in the forums. I did a lot of the early XNA demos. I've spent the last few years doing XNA contracts and odd jobs here and there. And I'm currently working at a small startup called Exodo Game Studios, who released a game called Guncraft, which, as you can imagine, is Minecraft with guns. You can get that on Steam, and that's the only advert that I'll do today for it. Right now, I work with Tom, help out where I can on MonoGame. Unfortunately, since MonoGame's kind of clean room version of XNA, I am limited in the amount of code I can write, but I create a lot of bugs for Tom, and Tom's very good and fixes those for me. So I've got a little bit of experience with MonoGame, and I'm working on some things that I can't talk about today. So what are we going to cover today? They've got 4 modules. They'll be around 40 to 50 minutes each. We've got some time for questions. If you're in the chat, then there's some subject matter experts out there who are going to help out, I hope. If the questions don't get covered, we will pick them up and we'll try and answer them at the beginning of the next session. So ask your questions and have fun, because we're going to try to do that. The first module is getting started. Pretty good introduction to how the code works, what the history of the product. Then Tom's going to take over for 2 sessions, and he's just going to make a game on Windows Phone.
I'm going to try.
We're going to try and make a game. That's a good
Hopefully it goes smoothly.
The demo gods are with us.
Let's hope.
Yes, that's right.
Yes.
And so we're going to do that, and then I will come back for the 4th part much later today, and we're going to port that over to Windows Store, and we're going to add some Windows Store variations to it, and I'm also going to give you a quick 3D primer. Tom's game is going to be mostly 2D, in fact, all 2D, and then I'm just going to try and get some of the 3D math in. Quick summary, we're on MVA today. There are a lot of videos out there. There's a fair number of video game tutorials and video game API tutorials that
different technologies, different engines.
Exactly. And there's also plenty of non-game stuff. I know many of you probably have day jobs where you have to write non-games. Lots of users, as you can see there, and the whole site is gamified. Depending on which sections you watch, you can get some points for it. And I'm not sure what happens to those points, but obviously points are always good.
Points are always good. And you're already on the site. You're there on the site, sign up for it, check it out. There's a promo code here on the slide, in particular for MonoGame. Take advantage of it, visit the site, sign up.
Okay.
And
we're on to the MonoGame. What we're going to cover in this module is the history, the background, where did it come from. I'm going to walk you through how to set it up. I'm not actually going to run through the installer. That would be very boring to watch. And then we're going to create a very simple project, have a look at the entry points and where you type your code. And finally, I will turn that into the fastest game ever. We'll cover a little bit at the end about the changes that you can see if you're an XNA programmer. In general, they're not much. That's the whole point of the API. So, what is MonoGame?
What is MonoGame?
That's always a good starting
Can you
point. Tom doesn't know, so we will explain. MonoGame's all managed code. We call into a very small handful of native libraries for things like content, but in general, it's all managed code. The source code is there for you to work on. Unlike XNA, if you have a bug, you can fix it. It's in GitHub. It uses the standard GitHub process for putting taking a fork, a pull request. You can push stuff to Tom. He'll pick it up and put it into the code. It's actually very easy to pull the code down and actually build your code against it. That's what I do. You can step into the code. It's kind of a joy after being stuck with XNA. Most importantly, it's cross-platform. XNA only ran on Windows Phone 7, though it will, in backwards compatibility mode, still run on Windows Phone 8. It will also run on Xbox 360 and PC, though it's limited that it will only run desktop apps. There was never an XNA version that would run on Windows Store. MonoGame's history, which we'll cover shortly, came about because people wanted to run XNA on other platforms. The list of platforms that we cover right now, you can see here: Windows, Mac, Linux, Windows Phone, all variations, Windows Store, Android, including Ouya. I believe there's a version that runs on Amazon Fire.
Yeah, there's some. We've gotten that to work. It's Android. It's a little bit more complex. Get things running on every variant of it. We have a version for iOS, of course, and just recently we have a version for PlayStation 4 that's available to licensed Sony developers.
Yep. And the whole point is that it's the XNA Framework API. So what we're looking for is the minimum amount of code change you have to do to your code.
Right.
It should just work. At least that's the theory. There's always a few gotchas in here.
Well, we have plenty of developers that have ported to different platforms and have seen extremely high amounts of code reuse. 80s, 90s. Almost 99% code reuse depending on your game.
It's certainly better than rewriting it. That's really the purpose here. If you want to get onto cross-platform these days, you probably would have to switch over to Unity or Unreal. And unfortunately, that's a lot of code rewrite. I'm actually going to let Tom talk about the history here. He's been around on this code a lot longer than I have. I vaguely remember Bill Reese, if Bill's watching, coming up with a thing called Silver Sprite back in 2010 when Silverlight came out.
Right.
So, Tom, tell us about the history.
So, MonoGame was started way back in the old days of 2009. Back then, this one developer decided, you know what, I love XNA. I like my little games that I'm building in XNA for the desktop and at that time for Xbox 360. And I'd like to try to take those games and port them over to iOS, a popular mobile operating system at the time. So he decided, let me go ahead and try to see if I can write a version of XNA with iOS backend to make my little 2D games render. And that's how MonoGame started. Originally it was called XNA Touch. That was because at the time, the version of C# that ran on iOS that was done by Novell, at the time through the Xamarin guys who were working with Novell, was called MonoTouch.
Before Xamarin existed.
Before Xamarin, actually. So it's when it was called MonoTouch.
MonoTouch, cool.
And so it was XNA Touch because, programmers are not always that creative about naming things. So the first release was strictly all iOS. And it ran there for a while. And Dominic Louis, at one point, he was contributing to the project. At a certain point, the original developer, Jose, he had to back out of it. He didn't have time to contribute to it. So Dominic took over as a lead in 2011. At that point, a lot of changes happened. He moved it over to GitHub, which was a great step. It increased the collaboration and the pull requests tremendously. I don't know how we would manage it if we weren't on GitHub. If we were on something SourceForge or something old like that, it would be impossible almost. At that time, he decided to rename it MonoGame. Again, mono because it's one. That's it. What's the relationship between MonoGame and Mono? None. They share the name Mono. That's it. That's the relationship there. At that point, they added Android, they added Mac, they added Linux. And this was all like a push to get more OpenGL platforms. They even added Windows using OpenGL. And that was really mostly just for testing it, at the time. So then at a certain point, we jumped in. Our small studio, we were developing games at that time for this new Windows Phone OS, and we were building stuff in XNA. And we were like, hey, we want to bring this thing to other platforms. And in particular, Microsoft was working on the Windows 8 and the Windows 8 store. And the big thing then was XNA doesn't work on Windows 8 store. And what are our options? And there was a lot of push for C++, but we said, you know what? Yeah, we can go to C++, a lot of rewriting, but in general, we'd like to stay in C#. We love C#. We love the XNA API. How can we make this work? So we came across a couple different libraries that tried to do the same thing that MonoGame does, but MonoGame seemed like the most viable, and they were very excited to have any contributions that we could. So at that time, our studio kind of got involved in developing the Windows 8 support with DirectX 11 backend, and we had it up and running in Windows 8 like basically when Windows 8 was first kind of released to the public in the pre-release version of the thing.
Yeah, I remember you. Were you the first or second game out?
First or second
Windows
game
8?
there, and and people didn't believe it was C# and XNA.
Everybody download ARMed. Good fun game.
So after that, shortly after that, we added Windows Phone 8 support because it was that simple. I really did it in a hotel room at Build. Basically, added Windows Phone 8 support. And then in 2014, Steve Williams and I kind of took over the project. Dominic and some of the other guys had to back away from the project a little bit, just taking too much of their time. So we kind of took over stewardship of the project at that time.
And this is the joys of open source. If the project ever goes away, like XNA did, the source is there. You can take over. You could be the next Tom. You could be sitting here in 5 years' time talking about MonoGame version 6. One thing that I'm pretty sure has probably already been asked in the forums right now is, what about Xbox One? We don't have anything to say about it because we don't know. We would love for MonoGame to be running on Xbox One if anybody at Microsoft's listening and wants to talk. If Shahid or Dave is on the call, they've probably already posted the link to the various mentions that Windows 10 will be cross-platform and universal apps will be available everywhere, which is a very vague allusion to what might be. Microsoft have announced nothing. So let all your Microsoft reps know that you want to see it there, and we hope that in a year's time or two we can talk about Xbox One. We'd love to be on every platform.
Hopefully sooner. You never know.
We've
been talking about it for a while, but we can't say anything right now because there's nothing set in stone just yet. But we're hopeful.
Given the chance, Tom will convert it in the hotel room as he did for Windows Phone.
Yeah, I can't quite do that.
So what games? It's always good to have a portfolio. That we have a video out on YouTube that for various reasons we can't show you today. So I'm going to leave this slide up here so that some of you can quickly copy the URL down and find it.
The video's fantastic. The music is fun and chiptune-y.
And we did think that Tom could maybe act it out today, but pew pew pew. That's about as much as we can do.
That. Not
so everybody go watch the video. Not now, because we're going to keep talking. This is our panic slide in case we weren't allowed to show the video, which has come in really good. Here's a list of probably the biggest games that have used MonoGame. Some of these are strange variants of MonoGames. Some companies take their own fork because they want to be more efficient, but it all comes from the same core code, and many of these people, even if they forked it, contributed things back. For example, the guys at Infinite Flight did a big chunk of the 3D code, I think, for MonoGame, right?
The original 3D code actually came from them, and then they kind of like dumped some stuff on us, I believe, and then we kind of like pulled it in and started doing some work on it and cleaned it up and got it integrated. Fez, Renaud, he contributed a bunch of code back from the work that he did when he was porting Fez over to Mac and Linux. The Bastion guys, they're great. They contribute a Chrome fork, which is out there, but we still haven't integrated. But I think at this point, it was a native code version of the thing, and I think native code is being removed out of Chrome, so I guess we missed our window. Skulls of the Shogun, those guys have basically, at this point, I think they ported almost everywhere. It's coming to PS4 soon. It's going everywhere, and the code is highly reusing code in it. 90% of it easily is reused across all the platforms.
You can see on here that there's been a recent rush of ports onto PS4 as the PS4 version has come out there. Most of these games have released in the last 2 months, I think.
In a couple of months.
Or coming up.
Dust is great. Tasmanian Tigers, done by Steve's studio out there in Australia. Scapegoat 2, Towerfall Ascension, which is really popular right now. Mercenary Kings is fantastic looking. Those guys did some awesome work there. Transistor, another game by Supergiant, the guys that did Bastion, and Apotheon, which is coming out, I think, early next year on PS4 and also on Steam.
And as well as these, there are many, many smaller games, probably people who haven't even told us.
There are more than we know. Yeah. Unfortunately, we haven't been able to track them that well. There's really a lot of games out there that we'd love to hear about. Let us know.
Okay, so let's get started on some of the tech stuff, because that's boring history stuff. Okay, before you can install anything, before you can run anything, if you want to develop store apps, you're going to need Windows 8, because that's what Microsoft say. You need Visual Studio 2013, and it's always good to be on the latest service pack. I'm not 100% sure if that's required, but get it anyway. You need to install the separate Windows 8.1 SDK. Links are all on there. And this one's kind of key, especially if you're running on either older hardware or some cheaper laptops. The way you develop phone apps and store apps is running through an emulator. And the emulator uses Hyper-V, which is Microsoft's virtual PC essentially solution. I'm going to click this link just to walk through quickly some of the requirements. Take you to this page, which has a lot of stuff on about the emulator. And this is kind of the section that you need to look at. Sometimes your laptops are shipped with these things turned off for whatever reason, I don't know. You may need to turn these on. You need lots of RAM. It's running a fake machine. And you need 64-bit version of Windows. And takes you down a little further and gives you some of the detail stuff there. If you don't have that and you can't run the emulator, you can still run the things on devices. You just have to plug the hardware in. It takes a little bit longer to deploy, and you've got to look over the other thing. So it can be done. It's just not fun. And finally, you need to install MonoGame. The download site lists the final releases. The 3.2. When did you release 3.2? It's been a while.
It's been a while. It's we haven't got into a good release cycle. At this point, we're working out how to do that more efficiently. We're trying to be more rapid and iterate on these things quicker. But a lot of people work off the development builds. If you're familiar with GitHub and Git and you're comfortable with getting dirty with some of this stuff, which a lot of monogame developers are mostly programmers, so they feel more comfortable with it. I usually work off the latest development builds. If you go down there to the development builds page, there's just a link, MonoGame for Visual Studio. Click it, it runs an installer and installs all the stuff, and you're done. It's there. But if you want to get to the source code, you can go to GitHub, fork it, download the zip. Either way, we work from that as well, and we're always trying to maintain it, make sure it's up and running. But if you really, really, really want stable, you can go to 3.2. But some of the stuff that we're talking about today isn't in 3.2. We're going to release a new update here pretty soon.
And to be clear, this is actually a binary build. This is like installing XNA Game Studio.
Exactly.
This isn't pulling the source code down. You've got to go and do all the Git magic to do that.
Yeah.
Right now, I should give you a warning, it is not signed. Tom is currently working on that. So you will get the Windows 8 smart screen. For those of you who've not seen it before, it's kind of hiding the security thing. You have to press the little more info button and then say install it anyway. And Tom promises
it's
safe.
I have the certificate. I just need to get back to the office and get it all set up and set up the build server. It's a little complex, and Andy prompted me on it, and yeah, we're going to get that done.
And we should point out that MonoGame is totally free, and free as in free, whatever the open source thing is. On Windows, you don't have to pay anything else. If you've got a Visual Studio through MSDN, the Visual Studio 2013 Community Edition runs just fine. So you can use that, or you can use your paid versions. If you want to run on other platforms, there are various license costs associated with that. Please talk to Xamarin if you're running on those platforms, and on the consoles, you have to talk to the console people. But MonoGame itself, once you have paid for those, is free. So it's been 15 minutes or so. So let's switch in and get some code.
Finally.
Yeah, finally code. And we're going to.
Are we not programmers here?
Yes, indeed.
All right, so Andy is going to try to get a project set up here and just basically deploy a project out there so that we can just see how the deployment process works, see what the initial project you get. We have some nice templates that created basically a basic empty project, not really empty, but basic project. And then he'll just show you just the high-level basics of how MonoGame runs. What's a game loop? How does it draw, content loading, and set up a very, very, very simple Pong game.
So just like XNA, when you're installing MonoGame, you're not installing a standalone product. I remember back in the XNA forums, people used to be confused. They'd install XNA, and then they would go to their start menu and say, well, where's XNA? I've looked on my start menu, and it's not there. So when you install MonoGame, just like XNA, it will put things into Visual Studio. So when you say File, New Project, underneath your Visual C#, and I believe you only show them under C#, but in theory, it works from any language.
Right, and yeah, I know people that have used F# with MonoGame. Totally works.
So we should probably add that under Visual Basic there.
We probably could.
There are 2 or 3 Visual Basic programs.
Or somebody could submit the pull request while we're here doing this.
That would be great.
That'd be awesome.
So we've added a whole bunch of Mono templates here. MonoGame Windows, that's the desktop one. Windows OpenGL. Tom mentioned that earlier. In general, you're never going to release an OpenGL-based Windows one. Why would you? It's you know.
I mean, you can. Some people do it just because of the the religious aspect of I want to be OpenGL. Download DirectX OpenGL. But it's fine.
But the most useful thing for this is if you are wanting to test on other platforms, it's great to have an OpenGL project that you can just build and run on Windows. Windows Store. And Windows Store XAML are 2 slight variations on how the project kicks off.
So if you want to use the XAML stack to add XAML controls, sometimes your ad networks want to use XAML controls, so that's where you'd jump in with that.
And I believe in theory the XAML one is slightly less efficient because it's having to go through the XAML stuff.
There's a little inefficiency there, but the benefit is you get XAML controls that you can overlay with your game or put behind your game. There's a lot of options there, and some people use it. Actually, I've seen people use the XAML version with actually making like business-style apps. They just happen to use MonoGame for a little bit of rendering, but the rest of it's all XAML. So.
Windows Phone 8 and 8.1, Universal Project, remember that, we'll come back to that later today, but for now I'm just going to pick Windows Phone 8.1.
And by the way, the Windows Phone 8.1 template was provided by Microsoft. They submitted a pull request to us and gave us those templates for Windows Phone 8.1 and the template for the Universal Project. Microsoft contributed to us. That was awesome.
Excellent. Thank you very much. Microsoft getting good in the open source area lately.
Oh, yeah.
I'm just going to run this. Those of you who've done Windows Phone development know that you're just going to run the emulator, and up comes a nice emulator there.
Oh, you didn't open the emulator first.
I did not because...
yours came up quick. Mine took forever.
Those of you who've done this know that the worst thing you can do is press this close button every time because you can actually leave this open and it will start up a lot faster.
Yeah.
This is the empty template. As you can see, the lovely cornflower blue background, and Microsoft thoughtfully provided a nice colored cube. The code for which I will use later. So let's have a quick look in here. Those of you who are XNA programmers are going to be a little bored because this is looking exactly the same.
Or excited that it's the same,
Yeah. As you'll see, the namespaces at the top actually still have Microsoft.xna in them. This is obviously for compatibility reasons. This means that you don't have to change all the using statements at the top of your code because that would probably take a long time and we would need tools to do it. So essentially this is a DLL assembly level replacement. You're going to see the same layout for the basic class. You inherit a game and call it whatever you like. It has the same setup at the top that you can create the graphics device. This stuff here is what's in the empty template, and this is for drawing the cube. So I'm going to kill this because we're going to write a different game. It's great editing this with a big font, isn't it? Everything's enormous.
Up, more. I think it's more.
There we go.
Oh yeah, you need those. There you go.
Okay. Now I've got a curly bracket missing somewhere, haven't I?
That one, right there.
Okay. This constructor, exactly the same as in the empty XNA template. It points to the content, and it gets a graphics device manager. For those of you who are new to game programming and have never done any DirectX, the graphics device is kind of an abstraction around the GPU. So when you're talking to it, you're sending things to the GPU. It's how you create objects that the GPU needs to use. I'm going to remove the code here for creating the cube. I'll leave that line in.
Yep.
And initialize, this is the first thing that's called after the constructor. This is where you would set up things that need the graphics device. So at the point initialize is called the graphics, the GPU is set up and ready to accept things. So you can load, you can set up the the shaders and things like that. Load content.
Well, I was going to say that, some people stick stuff in initialize, some people stick it into load content, which we're about to talk about.
Load content. This is specifically where you will pull things in your. You'd load your sprites, you'd load 3D models, you load effects, and anything that needs to be pulled in. It's called once, it's called upfront, and from that point on, your stuff's going to stay in memory. There is an unload content. In general, you don't use it anymore. It used to be for the days when content could get kicked out of memory. Modern computers don't do that. And then there are two key points here. These are update and draw. This is called the game loop. Game loops are in every game engine you'll ever see. They vary in how they're called. They vary in whether they can be multi-threaded. But in general, there are two aspects to it. And what this is to separate the updating of your game state from the drawing of your game state. And the way I like to think about this is that update is the thing that sets all the variables. So it's going to read the input device and it's going to move something from here to here. And draw is what takes the state that you've set and puts it at that position on the screen. So nothing in draw ever changes anything. Depending on the game engine, updates can be called at different rates to draw, and that's really why they separate them out. In XNA, if the game is running slowly, for example, XNA will actually skip draws. It will cut down to 20 frames a second, but update could still be running at 60, so that things still feel smooth even if they don't look smooth. This can be very important for things like physics engines, where if your physics engine actually slows down, then strange things happen. I'm sure you've all seen things flying off the world, or things that bounce, and instead of bouncing lower and lower and lower, they fly off the screen. That's usually because the physics engine's running slow. The top of draw, here is where we draw clear the screen to the good old cornflower blue. And I could argue here that cube rotation should be set in update. It's changing the state.
We're programmers. We like to argue things.
Yeah, we would love to. Yeah,
we can move it everywhere, all over the place.
The reason you can get away with it is because it's actually based on game time, and game time isn't going to vary. It's not based on input.
Right.
So we will get rid of all of these, and we'll run it now just to make sure that it still works. And I have missed something. There we go. Don't need that line either. So we should, in theory, be straight back to cornflower blue here. There we have. That's what a real MCXNA program should look like.
Don't close it.
Don't close it. Thank you, Tom. And I'm going to fire up a separate program here so that I can cut and paste, because we really do not want to do this typing. We're going to try and do this fairly quickly for you, because Tom's going to be the one who does it. And I really just want to show you the different things that you would put in. So we are going to write Pong in about 3 or 4 cut and pastes here. So, some variables. What do we need to think about in Pong? We have a ball, we have a paddle. One of the downsides when you're running the emulator is you can't do edit and continue. Tom, you said that if you're running on the device, you can actually do that.
Yeah, I mean, that's a lot of times we're starting here for Windows Phone just because it's kind of fun and interesting to have a version of the game that is in your pocket, right? So that's kind of neat to take that along with you. But if we're like building a brand new game, a lot of times we'll start with a desktop platform because, edit and continue works. The startup is a little quicker. It's just a little bit easier to work with at times. So those are some of the reasons why sometimes we start with that. But you can just as easily start with a phone project, or seen people start with the Mac project as well, if they're Mac-centric people. So
some variables there. Store the ball's positions and speeds. We're actually not going to load any content here because we're going to talk about that later.
Right.
What we're going to do is make a texture in code.
Ooh, fancy.
And so this is a good little trick that I've used a lot for being able to draw rectangles and lines and strange stuff like that in XNA.
Yeah.
So we make a new texture here. We're going to make a 1 by 1 pixel texture because it's just one color, so we can scale it to whatever size we need. And then you set the data on that from a single color array of colors. So what we've got there is the same as just loading it from the disk. I'm going to set the ball position, the ball direction. This is based on the center of the screen, and I'll set the paddle to the middle of the screen.
Let's see what you're
And there
copying.
really is. This is the update. So in update, we read the input, we move things around the screen, and that's pretty much it. You know, in a bigger program, and you'll see this with Tom, you don't put all the code in here. You'd have a list of things the game cares about. You often call that a scene graph. What else? There's various names for it, but it's... Imagine you're playing a first-person shooter. There is the world, there are players, there are vehicles on the screen, and you generally call into a separate class to do this. But we're going to break all the rules and put everything in one place here. And this is pretty much just about as simple math as you can get. I'll walk through it. It doesn't like to... I need to add my using statement here.
Oh, yeah. Luckily, it does it for you.
It does it for you. Thank you, Visual Studio. Yeah. So we're going to read the touch panel. We're going to make sure there's at least one touch. If there is, we're going to take the first one. You probably want to do different things with this. It's for us, I'm just going to take where it is, and we're going to track the paddle position X. The paddle is 40 pixels wide, so I'm going to subtract 20 from that. There's a lot of magic numbers in here. That's a bad thing to do, everybody.
I love magic.
Yeah, magic numbers are evil. We're going to move the ball. We've got some vector math here. Ball direction is a vector 2. So those of you who are new to game programming, probably thinking, what is a vector 2? You might call it a tuple. It's essentially
a point.
A point. If you've done Windows Form programming, you've certainly seen point. Vector 2 is a float version of a point. Points are usually ints, I believe. And this is just the XY position on the screen. And they're very common in game programming because when you're drawing things in 2D, that's what you need. And you'll see when I get into 3D later, there is a vector 3. That's what it's named. There's also a vector 4, which is a whole different ballgame.
Whole different dimension.
It's very funny.
Yeah.
So we practice our fake laugh now.
Yeah.
And I'm going to multiply that by the elapsed game time. So the reason for this is games can run at different frame rates. And I'm sure you've all seen games that drop down to 30 frames a second. And when the ball's moving across the screen, we would like the ball to move the same amount, let's say 20 pixels per second. If I just add 1 every frame and the game runs at 60 frames per second, then I'm going to get 60 frames a second, 60 pixels per second. That's great. But what if I run on a slower device and it only can run at 20 frames a second? Well, at that point, the ball's just slowed down. It's now only moving at 20 pixels a second. So what you can do, and this is essentially basic physics, you can multiply it by the game time. And the game time tells you how much time has happened since the last time we called update. And this keeps the speed of the things moving across the screen at a nice constant rate.
Right. At least over time they'll be constant, but you might not get as many frames in between because you're running slower. So they're making bigger jumps.
So the distance from here to here is the same amount of time. And this is just a speed function that I put in that we're going to speed up. Bounce the ball. This is pretty simple. I'm going to compare it against the left and right of the screen. And if I'm near the left or right of the screen, I'm going to invert the direction of the X. This is another vector 2. And it's either +1 or -1 in each dimension. And I'm going to slightly speed the ball up. So as it bounces around the screen, it speeds up. Same thing for the top and bottom of the screen. And then this is if you miss the ball. So if the ball position hits the bottom of the screen, then we actually reset the position to the middle of the screen. This is where you knock one off the score, remove the number of lives. There's no HUD in this game. This is not a finished product. And I sort of skipped over this one because it's gone off the edge of the screen, the big font. So let me put a carriage return in here for you. This checks the top of the screen, and this one actually checks against the paddle. And the math in here is kind of wrong, but it will do for the purposes of this demo. So if you're really lucky, you'll get to see the ball pass through the corner of the paddle. And finally, I said this was going to be in 4 pastes. I may have said 3 pastes, the draw. And we will talk about...
That draw looks very simple.
Yeah, it is. Because we put all the code for doing the changing of the state in update, all we have to do on draw is call the APIs that draw pixels to the screen. And since we know where the ball is, we say draw the ball here, and the bat, we draw the bat here. And there's no other math. We're not reading anything. We're not moving anything. We're not changing anything. At the point where you call draw, your game state should be fixed. Everything should have been decided. You should be able to call draw multiple times in succession, and nothing should ever move on the screen. And what we've got here is the MonoGame API for drawing 2D sprites. It's a batch product, batch process, and we'll talk about why that is when we get to Tom's thing. But essentially, you have a begin and end, and anything you draw in between gets all drawn together. Single pixel sprite, if you remember, was our 1 pixel texture. This is the position that we draw it on the screen. This is the color. We're going to draw the ball in red and the bat in blue. And finally, over here, we have a scale. All the other parameters that I'm skipping over are the default parameters. I think this one's probably a rotation. This one's the rotation center. This allows me to flip things. If you look at MSDN, you'll see the documentation for XNA, and this is exactly the same.
That's actually a good point. If you're stuck and you want to look at something, look at the XNA documentation. Just about any XNA tutorial that you've seen usually applies to MonoGame pretty directly, with very minimal changes, if any, a lot of times. So it's a great place to look for this kind of stuff.
Okay. And then this parameter here, and this is why I've used the long version of spritebatch.draw. This is the scale. If you remember, our texture is a 1 by 1 pixel. Even on a very old phone, that's not going to be a very good game trying to catch a 1 by 1 ball. So we scale the ball by 10, and we scale the bat 40 in the X direction. Do you remember that minus 20 at the top that I said was a hard-coded number? That's half of 40, and we scale it by 10. Now, if my cut and paste have all worked, I will be able to run this. And we have a bat and a ball. And the mouse works like the touch, although I believe I can touch the screen.
Oh, yeah.
There we go. And you guys can hopefully see, oh, yeah, you can see the little circle there. I don't know why it changed to a square there. And if I let that come around and miss, the ball will reset to the middle and off it goes. And it gets faster and faster. So
Awesome.
What we've done there is write probably about the simplest game you can write. There's less than 50 lines of code, I think, in there.
Yeah.
And most of it is weird math about bouncing a ball. Pong's a great game to start with. There's almost nothing to it. It's very easy to find variations on there to learn new things. I often use it if I'm trying to teach people effects and shaders, because you can apply fancy shaders to them. If you want to test particles, every time the ball bounces, write a particle engine that works in Pong. Don't go out there and start with a first-person shooter just because you've seen that. Pong's a great one. I think a more recent Hello World app is Flappy Bird. People seem to love to do Flappy Bird. And if you think about it, it's not too dissimilar to Pong. There's 2 things moving on the screen at a time. So start simple. Keep that going. Let's switch back to my slides here and see if we...
So we're going to get into this next section, which is XNA differences, just to give you a high-level idea of, there are some differences between MonoGame and XNA. So what are those things?
So probably the first key thing is the platforms. We don't have a version of MonoGame that runs on Xbox 360. That's not something that's open. It's not something that we could do even if we wanted to.
And we don't need to.
We don't need to. Microsoft do a great job of it.
Yeah. Same thing with Windows Phone 7. When Windows Phone 7 came out, there was XNA support for it. It was great. We don't need to provide that. It's there already. XNA is alive and well. You can totally get it today and run it.
Yep. Download from the usual place. You can even share your code between the projects. You do kind of get stuck in Visual Studio 2010, but there's no reason that you can't just share the exact same source code. I do it on several of my projects, and they will run quite happily on Xbox 360 and all the other platforms.
You can also kind of coax it to run on 2012 as well, but it's a little tricky.
There are workarounds out there. Content projects are handled fairly differently, and we have some slides at the end to show how that works. The content pipeline hook-ins were done at a very low level and made to work in Visual Studio Express, which was not something we had access to. As of a couple of weeks ago, when they announced the Community Edition, you are allowed to do add-ins on the free version now. So we may have done things in a different route, but we've done the way we've done.
We might try to do something a little different now that that's changed, because for a long time that wasn't an option. And they heard feedback and they did it.
There's still a few gaps in the APIs, nothing major. I mean, I'm sure we're well over 90%. And the stuff that's missing is stuff that you don't notice very often.
And it's a lot of things that are kind of more advanced, things that, some of the higher end guys run into, but most people don't run into. Every once in a while somebody comes across them, and we're trying to get to them. It's just that, it's time. We have day jobs, we also do stuff, so we try to balance it, But some of the stuff is vertex buffer instancing, something we've been needing to get in there. Andy's bothering me about it. We totally need to get it in there for him. There's some pack vector formats that are kind of exotic that we don't have in there. It's not that we can't support them, it's just we just haven't implemented them yet. And exact support, we have it. It's just not, exact is a huge thing, and it's really complex. And while we'd love to support more of it, it's kind of a complete black box. We don't know anything about it. We're kind of just figuring it out as we go. So but the basics work. A lot of games have shipped using it.
Especially 2D. 2D's, as Tom mentioned in history, is much more mature and has been around a lot longer. And you're going to find if you have a 2D game, it will probably port with almost no changes.
And the 2D under the hood is implemented, using the 3D API. So a lot of the 3D stuff works just as well.
Yeah. No support for Xbox Live services, or for that matter, any services on Steam, Apple, PS4, whatever your particular flavor is. And there's been a lot of discussions. Should MonoGame try and provide for example, a leaderboard API? For anybody who used XNA on Xbox Live Arcade, there's a leaderboard API. Should we make everything look like that? And part of the problem is that the other services simply don't look the same underneath. And
also the Xbox Live support was designed in a time that was designed, 8 years ago, 7 years ago. The world has changed. Yeah. Friends lists have changed. What you expect to see there has changed. So trying to make all that work under that API is probably not the best choice. So for now, the APIs are there. They mostly don't do anything. So it's not really that useful to you. There was some work to kind of implement a back end for it, but no one, as you were saying, it's like somebody has to run it and everything. So at this point, that's not there, but that's fine. There are C# bindings for calling into Steam APIs. There are C# bindings for calling into iOS APIs for your back end services, and you're free to use them. It's pretty easy. A lot of games usually end up having a secondary source file that has the implementation for iOS and one that has the implementation for Steam, and they switch out the build which they need for a particular case. It's usually pretty straightforward. So the stuff like that, you kind of have to work it your way out. But at least for the networking part of it, we do support the low-level networking pieces, like sending packets and making connections. That's there. It's not got as much testing. Not as many people use it, especially nowadays where a lot of networking is done with async code and REST APIs, so you're all doing HTTP. But it's still there, and people are using it in games even today.
Yep. So as Tom mentioned, the networking works. It's sitting on top of a great open source library called Lidgren. And Lidgren is a reliable UDP library, for those of you who know what networking is. And somebody way back in time implemented essentially the Xbox-style networking API on top of Lidgren, and it works. Unfortunately, getting any kind of networking working on a PC is kind of a black art. You'd be surprised.
That's a whole different talk.
Exactly, that's a whole different.
It has nothing to do with MonoGame. It just has to do with networking.
We have a few additions. Because we're open source, we're not stuck on a release cycle like Microsoft would be, and we don't have to justify it to program managers or committees. So we just say, Tom, this is a good idea, and Tom says that's great. So many classes have additional APIs on. There's a lot of helper classes in the math. We may even have some C# extension methods on some of the classes. We have visualizers in Visual Studio to visualize matrices and
there's some debug lines.
There's some value add in the debugger there. And again, a couple of examples here. We support multiple windows straight out of the box. You don't have to write your own stuff there.
That was something that our studio did. We had a project where we needed to have multiple game windows, and out of the box, XNA doesn't support that. You can kind of cobble it together, but it doesn't support it. We thought if we're going to do this anyways, we might as well see if we can enhance the MonoGame API to support this. So if somebody else wants to do this on the desktop, they can. And it's there. You can go and use it today, and we're using it in shipping products.
And the future, we would love to extend it. We're kind of stuck a little right now that most of the work is people porting XNA games, so changing APIs is very hard. We don't want to upset anybody, but we're well aware that XNA and therefore MonoGame is based on a DirectX 9 style API. And there were a lot of things that were nice that were added in DX 10, 11, and
XNA was kind of like a mix, right? It was like it would use DX 9 under the hood, but it actually had some concepts from DX10 and DX11, with state blocks instead of having individual states, and that was a great change. I think that happened in
XNA 4, I think.
Yeah, 4 is when it introduced that, and that's great because actually that almost completely applied when we started adding the DX11 backend. But going to DX12, which is what we're looking at, things are much different. So we're still talking about how to approach that, and DX12 is still a little bit out. But we're trying to make sure that at least on day one, we have some DX12 support.
So if you have good ideas, Tom's very active in the issues on MonoGame. Put your requests in. Give us a reason why. We get a lot of requests. We'd like some, prioritization. So don't just say, please implement DX12 unless you have a reason for it. Content pipeline. Quick summary for those of you who've not used content pipeline.
So the content pipeline basically is something that's kind of fundamental to kind of understand. It's a little bit different about XNA, and I think a lot of people that start out with games don't get used to this process, and it's something you really should get used to because it's going to bite you in the end.
And I think it kind of comes about from, if you're a big game studio and you're EA, as a programmer, you just say, hey, I'd like to load this model, and it just magically gets loaded into the engine. And if you're a small indie studio, you try and load this model, and you realize that, how do I load an FBX file? That's kind of crazy. And you start doing some research, and you realize that there's a whole API about loading FBX files. And you wonder how somebody like EA does this, and then you realize that, well, they have a team of about 50 people called the Tools team that deal with converting projects. And so Microsoft came up with this great concept called the content pipeline, which kind of virtualizes what happens when you bring content into the game.
And that's awesome. I mean, it's really awesome that they took the time to add that. They could have just as easily said, oh, just load PNGs and load WAV files and you're done. But by adding a content pipeline in there, they really kind of like pushed indies to kind of think about it in a more professional manner, how you'd approach these kinds of things. And it's tremendously important to getting to other platforms that you use a content pipeline so that you're not trying to load JPEGs and PNGs or like FBX files at runtime into your game engine. That is slow, error prone, and nothing you ever want to try to do. Even though people insist on doing it, and we support some of it, it's something you really won't want to be doing.
Yep. Different platforms have different APIs. Some of them can't even load a JPEG at runtime. It would be too slow. Some of them are big endian or little endian. Do you know which way around they are? I can never remember.
Yeah.
So the content pipeline transforms that at compile time or at build time. So you provide your FBX files and your JPEG files and your WAV files, maybe your platform doesn't even support a WAV file. Everything's modern and MP3. So you provide that, and then when you compile your program, the content pipeline process transforms that into what are called XNB files, and they are a platform, mostly agnostic data file. Many times the format in there is similar to what the GPU or the sound processor on that machine needs to do.
I mean, the high-level part of the format is kind of platform agnostic. Then there's details in there like take for a texture, for instance. It loads in you load in a JPEG or a PNG, or we actually support the MonoGame version of the pipeline actually supports loading Photoshop files. You don't want to read a Photoshop file at runtime. That's crazy. So the pipeline reads the Photoshop file in, converts it into a texture. It then runs it through the native compression for that platform on the Windows platforms. It's DXT compression. It compresses it that way and stores it in the XNB so that at runtime, all it has to do is load the XNB, and the texture data can be read out, stuffed into memory, sent straight to the GPU, and there's no extra processing to be done. You don't have to parse the Photoshop format at runtime, which is just slow, and you don't want to be doing anything like that.
So how did Microsoft design this? It's pretty much in 3 steps. We have importers. The importer is specific for the time. So there's a JPEG importer, a FBX importer, a .x importer. All of these are extensible. You can write your own. The importer brings it in between the content. A processor is kind of a translation tool. That turns it from whatever format it is into something that's going to be saved out later. And the writer then writes it out into the runtime format. All 3 of these are something that you can produce yourself. Microsoft shipped a bunch with XNA. We ship a bunch with MonoGame. Microsoft uses a Visual Studio content project, which is built into Visual Studio. MonoGame uses a MGCB file.
My clever acronym for MonoGame Content Builder.
It's a command line tool, but there's a GUI tool that sits on top of it too. I'll show you that in a moment. We support everything that XNA supports and some extra ones besides because of the libraries we use to pick them up. And we fully support the same custom processors. The code is exactly the same. One of the projects I'm working on, we took a fairly complicated skin model processor that did a bunch of compression, hid bones, removed bones, and we ran it through, and the content pipeline ran, I think, the second time after you fixed a bug.
Yeah.
So it was very close, and I think we were the first ones to put something that complicated through it. So.
Possibly. We've been testing it for a while, but yeah, it's a complex process, and we're still working it out, and we need people to use it and give us feedback so we can improve it.
I'll quickly run through the demo. And a final note there on this slide that some people still just build their stuff using XNA. That's perfectly okay. The XNB files are binary compatible with MonoGame, and that's actually very useful if you're still writing a game for Xbox 360 or desktop PC, and you're only using MonoGame to hit the other platforms.
Right.
So quickly.
Going to your demo now. So he's going to demo a little bit. So he's going to be showing the pipeline GUI tool. The GUI tool is actually kind of new. It's only been around for a couple months. It was the need for, since Visual Studio would include XNA content through a content project, the problem that we had with that is that works great for Visual Studio, but we also have the desire to support Mac machines and Linux boxes as well, and let people be able to develop on those platforms. So in order to let people develop on those platforms, we couldn't just be so specific to Visual Studio in that format. So we developed the pipeline tool and MGCB as a way to work in one place that works common between Windows, Mac, and Linux, so that people using those desktops can process content just as easily as you can on Windows.
So this is the GUI tool, and you'll see that it pretty much looks very similar to the way the old content projects were laid out. In fact, there's an import where you can actually bring your content project in.
Andy, why don't you zoom in on that a little bit because you can't see it. Use that zoom in tool there. I think that'll help people see it a little bit better. It's a little. We realized when I put this on there that we don't scale fonts appropriately. We should probably look into that. There you go.
Actually, I need to use Control 4. There we go. Now I can move my mouse. So we have an import option. It's a one-way import. Once you've imported it in, it won't save it back to the content project file.
It's really useful to get started. A lot of people use it to just
if you have a big one, it will open up a content project just like this one. These are exactly the same files that we bring in on XNA. Down here, you can actually see that we have settings for it. We say which platform we're going to build for. And then here's all the platforms in here.
Lots of them.
We have the profile, reach and high def, just like in XNA.
Yep.
And the references here is how you add the links to the content pipeline DLLs. It's not the best UI right now.
It's not as polished as we'd like it to be, but we're working on it.
You need to make sure to put a relative path in there so things still work. So that's kind of the dirty edge. The rest of this tool is actually fairly mature now. I use it every day. It's very easy to run manually. Tom's recently added it to the templates, so you can add an MGCB file into your Visual Studio project, and it will run.
Mostly for this presentation, we thought, you know what, it's time. Let's hook them into the templates, and it's remarkable. It's a night and day difference in how to process stuff. It's really exciting to see.
Just like in XNA, you have the properties down here. You can set color key. These are all exactly the same properties. And the reason for that is the properties actually come from the content processor. So we don't do anything special here. We just do what XNA does, where we look at the content processor.
You know, some other things to kind of point out, I guess. One thing that the thing supports that Visual Studio never supported is undo redo. It has infinite undo redo. If you make a bunch of content changes you don't like it, undo until you're done with the thing and get it back. You couldn't do that in Visual Studio. We added it there because it was something that we felt was a missing piece there. You can change properties, undo them, redo them. It's great. You can multi-select and do the same thing. It works fantastically.
Okay, that's it for part one today. So a quick wrap up. MonoGame is the cross-platform XNA compatible replacement. It is, many people have said XNA is dead, long live MonoGame. It's
the spiritual successor.
The spiritual successor, I like that. We've shown you how to set it up. It's pretty simple. Everything's downloadable. Everything's certainly free on Microsoft platforms now. We've shown you the basic game loop. If you find any XNA samples, they are all going to run. They're all going to talk about game loop, game state. And we showed the small example of what goes into each thing.
Right.
So if you've got any questions, please post them in the forums. We're going to take a 10-minute break now. Post them in the chat. They're not the forums. That's right. You guys are in a chat. And if there's anything that's unanswered, we'll pick it up in 10 minutes' time.
All right.
Thank you very much.